Hi Chem students, I want to show you a couple buffer problems, very simple basic ones, so that you can understand how to use the Henderson Hasselbalch to solve these. It starts off by just knowing that you've got a buffer system, and these first two are very easy because the concentrations will be given to you in the proper format. So here we go. What's the pH of a mixture that's 0.25 molar of HCN and 0.15 molar of LICN? You're not told this is a buffer, but you should automatically see that it's a buffer because they have the common ion. There's an acid with the CN. Here's a salt with the CN. They've got a common ion. So that being said, how do we go about solving this type of problem? Well, we know the Henderson-Hasselbalch equation says that the pH of our system is equal to the pKa plus the log of our base concentration divided by our acid concentration. And these aren't just any old concentrations, they're our initial amounts. And so we have to realize that our acid is obviously the 0.25 molar HCN, and this is a salt, but what kind of salt is it? It's a basic salt. So that's playing the role of our base. So all we have to do is plug in our numbers. We're given the Ka as 6.2 times 10 to the minus 10th, so the pKa is equal to the minus the log of that number, 6.2 times 10 to the minus 10th. So I can start to set this whole problem up as pH is equal to 9.208. I'll keep an extra digit for now, plus the log of this ratio here of 0.15 molar divided by 0.25 molar. So if I do that mathematics right now, I get 9.208 minus 0.222. If I do that, if I put that all together, my pH is 8.99. So that's what my calculator gives me. 8.99 would be the pH. It's a very weird, very weak acid. So you're thinking to yourself, how in the world can it be, if I've got an acid in there, how can it be a basic solution? Well, we've got a base in there as well, the LICN. So together they make a basic solution. Okay, let's go on to our other problem. Try this one out. What's the pH of a buffer solution created when there's some ammonia, and that ammonia is in with ammonium chloride, and we're given the Kb for ammonia. Now, immediately you should say, well, I know what my base is because ammonia is the prototypical base. So this must be a salt that contains the common ion with ammonia's equilibrium. It does. NH4 plus would be created with NH3 if NH3 was put in water. So this is a salt, but it's acidic. So there's our acid. Our acid is the ammonium chloride. Our base is the ammonia itself. But we're given a Kb, so there's a problem. Well, here's the good news. We can find the Ka for this real easy. It's going to be 1 times 10 to the minus 14th divided by the 1.8 times 10 to the minus 5th. And that equals, if I do that math, that equals 5.556 times 10 to the minus 10th. And therefore the pKa is very easy. It's just minus log of that number. If I do that, I get 9.255. All right. There's another way to get that, by the way. You could take the pKa and the pKb. They have to also add up to 14 for any particular acid or base. So we're okay doing it this method though. So now we've got the pH is equal to 9.255 plus the log of this ratio that I get, which is the base 0.27 molar divided by the acid 0.42 molar. And when I do that, I get 9.255 I end up with 9.06. So there you have it, using the Henderson Hasselbalch, very simple. A lot simpler than the earlier video, which did not use it. It actually went through the entire equilibrium process there. So you can use either way on the test. This will be a quick, short one right here. If you use the Henderson Hasselbalch, you will not be given the equation. You have to memorize it yourself. So remember, pH is equal to pKa plus the log of the concentration, the ratio between the base and the acid.